Hello students, today we are going to solve a past paper type question from Edexcel IAL M1 syllabus on the topic kinematics velocity time graph. Now, I am going to give you certain hints which are going to help you while solving the past paper questions as well as in your exams. First of all, many students what they do is looking at the length of the question, they don't read the full question carefully. But keep it in mind that each and every word of the question may carry some information. So read everything very carefully and mark the important things you find in the question. So let us read this question. Keep a pencil in your hand. They said that a car starts from rest and travels along a horizontal straight path. Travels along a straight horizontal path starting from rest from point A. It accelerates uniformly at 0.8 meter per second square for 20 seconds and maintains the speed. It maintains the speed for next 40 seconds where it is given that t is less than 20. The driver sees the signal, so he applies the brakes. The car decelerates at 0.5 meter per second square for next 20 seconds and reaches the signal at B. The total distance traveled by the car from A to B is given to you 864 meters. You have to sketch a velocity time graph. Now, first of all, to sketch the velocity time graph, we have to find out the final velocity as the car reaches the signal. So keep it in mind that they have said the car is accelerating uniformly. Now, car is accelerating uniformly means we can use SUVAT equations. Now, the car is starting from rest. So, what will be the initial velocity? Obviously, 0 meter per second. Now, the car is accelerating at 0.8 meter per second square and it is taking 20 seconds to reach the particular velocity. So let us find out the velocity. We want to find out the final velocity here. So we'll use the equation V is equal to U plus AT. Now U is 0, A is 0.8 and T is 20, which gives 16 meters per second. So let us now sketch the velocity time graph. So this is the time axis here. Then This is the velocity axis, y-axis on which will show the velocity. So let us mark on this graph. So first of all, time t is 20 seconds here. And the velocity reached by the car is 16 meters per second. So, and since the car is accelerating at a uniform rate, this will be a straight line. Then this velocity the car is maintaining for next 40 seconds. So this will be 20 plus 40. So the car is going to maintain this velocity up till here. So from here to here. After that, the car is going to decelerate and stop at a means it will reach the point B. So let us see what will be the velocity at point B. We have to find out the final velocity at point B. So now for that, we'll take the initial velocity as 16. The deceleration of the car is 0.5. That means A is negative 0.5. Deceleration is negative acceleration. And it is decelerating for next 2t seconds. So t is capital 2 to capital T. So again use V is equal to U plus AT. So 16 minus 0.5 into 2t which is 16 minus t. So it will be somewhere here. So that will be the nature of the velocity time graph. So this velocity here is 16 minus t. Now it is given that the total distance traveled by the car is 864 meters, and we know that the area under velocity time graph is the distance traveled. So I will divide this region in different geometric shapes. So first it is a right angle triangle, then there is a rectangle here, and then there is a trapezium. Now since the car is decelerating for next 2t seconds, so this will be 6t plus 20. So total area under the graph, area under the graph will be now divided in three regions. One is the right angle triangle. So the area of the right angle triangle will be half into the base of the triangle is 20 and the height of the triangle is 16. Then the rectangle, for the rectangle the width is 40 and the height is 16. So it will be 16 into 40 and finally the area of the trapezium, that is half into the sum of the parallel sides. So one of the parallel side is 16 and the other parallel side is 16 minus t. Into the height of the trapezium, and the height of the trapezium will be 2t. And this total area is same as the distance traveled by the car up till the point B, and that is 864 meters given to you. Let us simplify this. So this is 160 plus 64t plus, now here 2 will get cancelled. So you are getting t into bracket 32 minus t, and that is 864. So let us simplify this, get 864 on the left side, that will become negative 704 plus 64t open out the brackets, this is 32t minus t square, that is equal to 0. So get the quadratic equation in the standard form in t, capital T. So t square minus 96t and plus 704 equal to 0. See that I am making the coefficient of t square term positive so that it is easy to solve. Now I can just solve this using the calculator, which gives me two values of t. T is equal to 88 or t is equal to 8. But it is given that t is less than 20, that means t is 88 is not possible, and hence the only value of t acceptable is t is equal to 8 seconds. So if I put it back here, 20 plus 40, t is 8. 8 4s are 32 plus 20, that is, this is 52. And 6t plus 20, that is 6 into 8 plus 20, that will be how much? 68 seconds. So this point is 68 seconds. So that is the value of t we have got. Now, in the next part they have said, suppose the car continues to decelerate from B at the same rate of 0.5 meter per second square, it will stop at C. Find the total distance from A to C. So now, what will be the velocity of the car at point B? Put the value of t here, 16 minus 8, that is 8 meter per second. So, I will consider now the journey from B to C. Now for the journey from B to C, the initial velocity u is 8 meter per second. Now the car is going to stop, so the final velocity v will be 0 meter per second, and the acceleration is again negative 0.5 meter per second square, because the car is decelerating at the same rate, and I want to find out t for this journey. So this is the extra time taken for the car to stop. This is the extra time taken by the car to stop. So again I will use v is equal to u plus at. So v is 0, u is 8, a is negative 0.5 into t. So if I solve that, I'll get t at 16 seconds. So that means the total time taken by the car to travel from A to C, total time taken by the car to travel from A to C will be how much? That will be 68, because it has taken already, as you can see here, 68 seconds to travel up till B. So 68 and extra 16, so that is total 84 seconds. So if I sketch this graph again, it will be like this. So I'm going to get a full trapezium. So the car has started from rest and has attained the velocity of 16. Then it has maintained the velocity of 16 for next 40 seconds, and then it has decelerated and completely stopped at C. So let us fill this figure. So this is 0. This is 0 here. Then this is 20. Then this is 52. And finally this is 84. So total distance traveled by the car from A to C will be the area of this trapezium, and that will be half into 84. That is one side of the trapezium. Now this side is 32. To 52, that is, this is 32 seconds, so this side is 32, and the height of the trapezium is here 16, that is the velocity reached by the car. So that comes out to be how much? Half into, so 16 and 2 cancels, that is 8 into 84 plus 32, that is 116. So 116 into 8, that is 928 meters. So that is the total distance traveled by the car from A to C. I wish you are understanding this properly. Thank you, students. Enjoy the day. Bye.